Every time you send information online, whether it's a message, a password, or a bank transaction, your data travels through Wi-Fi networks, routers, internet providers, and many other systems before reaching its destination. This journey exposes your data to various risks, especially if the information is sensitive. Protecting your data from prying eyes is crucial, and that's where encryption comes in. In this video, we'll explore how encryption and decryption work to keep your information safe as it moves across the internet. Imagine sending your bank password or credit card details online. Without protection, anyone intercepting your data could read it. Encryption is the solution to this problem. It transforms readable information into a form that only authorized parties can understand. This process is essential for online banking, credit card payments, login passwords, messaging apps, and secure websites. Encryption ensures that even if someone captures your data, they can't make sense of it without the right key. Encryption is the process of converting readable data, known as plaintext, into unreadable data, called ciphertext. This transformation makes the information useless to anyone who doesn't have the secret key needed to reverse the process. Encryption is like locking your message in a box that only the intended recipient can open. It's a fundamental technique used everywhere online to keep your private information safe from hackers and unauthorized access. Let's see how encryption works with a simple example. Suppose Alice wants to send the word hello to Bob. First, her computer converts each letter into a number. H equals 72, E equals 69, L equals 76, L equals 76, O equals 79. Next, a secret key is chosen, let's say it's 3. The rule is to add 3 to each number, resulting in 75, 72, 79, 79, 82. These numbers are then converted back into letters, forming the encrypted message KHOOR. Now, even if someone intercepts the message, they see only KHOOR, which is meaningless without the key. In encryption, the original readable message is called plaintext. After applying the encryption process, the result is called ciphertext. The method used to perform this conversion is known as a cipher. Think of it as a recipe that takes your plain message and turns it into a coded version. This coded message can safely travel across the internet, and only someone with the right key can turn it back into its original form. Let's visualize the flow. You start with plaintext, apply a cipher, and get ciphertext. This encrypted message travels across the internet. Even if an attacker intercepts it, they only see the ciphertext, which is meaningless without the key. The process keeps your information safe until it reaches the intended recipient, who can then decrypt it and read the original message. Secret key is the heart of encryption. Without it, the ciphertext remains unreadable. In our example, the key was simply the number 3, but in real systems, keys are much more complex. Only the intended recipient who knows the key can decrypt the message and recover the original information. This ensures that even if someone intercepts the data, they can't access its contents. Once the encrypted message reaches the receiver, it must be converted back to its original form. This process is called decryption. Using the same key, the receiver reverses the operation, subtracting 3 from each number in our example to get back the original message, hello. Decryption is the mirror image of encryption, restoring the hidden information so it can be understood. In real-world systems, we don't use simple rules like adding 3. Instead, powerful encryption algorithms such as AES and RSA are used. These algorithms perform complex mathematical operations, making it nearly impossible for attackers to break the code without the key. They are the backbone of modern security, protecting everything from online banking to private messages. The full process starts with plaintext, which is encrypted to become ciphertext. This ciphertext travels across the internet, protected from attackers. When it reaches the recipient, decryption restores the original plaintext. This cycle ensures that sensitive information remains secure from start to finish, no matter how many systems it passes through. Encryption is everywhere in our daily lives. When you log into your bank account, send a message, or make a payment online, encryption is working behind the scenes to keep your information safe. It's a silent guardian, ensuring that your private data stays private even as it travels across the world. Encryption and decryption are two sides of the same coin. Encryption hides information, making it unreadable to outsiders. Decryption brings the information back, allowing only authorized users to access it. Together, they form the foundation of secure communication online, protecting your data every step of the way. While our example used a simple rule, adding 3 to each number, real encryption needs much more complexity. Attackers can easily guess simple patterns, so modern encryption relies on advanced algorithms and unpredictable keys. This makes it extremely difficult for anyone without the key to break the code and access your information. The strength of encryption depends on the secrecy and complexity of the key. If the key is weak or exposed, attackers can easily decrypt your data. That's why secure key management is a critical part of any encryption system. Only trusted parties should have access to the key, ensuring your information stays safe. In summary, encryption transforms readable data into unreadable code, protecting it as it travels across the internet. Decryption restores the original information for authorized users. Together, these processes keep your sensitive data safe from attackers and ensure privacy in our digital world. Understanding encryption and decryption is key to staying secure online.